All right, let's dive into the fascinating world of tides. The tides we experience on Earth are mainly caused by the gravitational forces exerted by the moon and the sun on our oceans. So, what exactly are these gravitational forces and how do they create tides? Well, you see, every object in the universe that has mass attracts every other object with a force we call gravity. The strength of this force depends on the mass of the objects and the distance between them. In the case of the Earth, Moon, and Sun, their gravitational forces are constantly interacting with each other, and it's these interactions that play a significant role in creating tides. The gravitational pull of the Moon causes the water on the side of the Earth, closest to the Moon, to bulge outward. This bulge is the result of the water being attracted towards the Moon due to its gravitational force. At the same time, the Earth is also being pulled towards the Moon, but since the solid Earth is more rigid, it doesn't bulge as much as the water. This creates another bulge on the opposite side of the Earth, as the water there is essentially left behind. Similarly, the Sun's gravitational force also causes a bulging effect on the Earth's oceans, although its effect is about half as strong as the Moon's due to its greater distance from the Earth. These bulges in the water, caused by the combined gravitational forces of the Moon and the Sun, are what create the phenomenon we know as tides. In the next section, we'll explore the difference between high tides and low tides, and how the Earth's rotation plays a role in their occurrence. Now that we've learned about the gravitational forces exerted by the Moon and the Sun on Earth's oceans, let's discuss the difference between high tides and low tides, and how the Earth's rotation plays a role in their occurrence. High tides are the result of the bulges in the water we mentioned earlier. When a particular location on Earth moves through one of these bulges, due to the planet's rotation, the water level rises, creating a high tide. In contrast, low tides occur when a location moves through the areas between the bulges where the water level is lowest. So how does the Earth's rotation factor into this? Well, the Earth rotates on its axis once every 24 hours, which means any given location on the planet will experience 2 tidal bulges and 2 low points approximately every 24 hours. This rotation results in most coastal areas experiencing 2 high tides and 2 low tides each day. However, it's important to note that this is a generalization, and the exact timing and number of tides per day can vary depending on the location and local factors. To sum it up, the difference between high tides and low tides is a result of the Earth's rotation moving locations through the bulges and low points in the water caused by the gravitational forces from the Moon and the Sun. In the next section, we'll discuss the roles of the Moon's and Sun's positions relative to Earth in determining the strength and frequency of tides, as well as the effects of their elliptical orbits. Moving on, let's examine how the positions of the Moon and the Sun relative to Earth play a crucial role in determining the strength and frequency of tides. We'll also look at the effects of their elliptical orbits on this phenomenon. As we've discussed earlier, the gravitational forces of the Moon and the Sun are responsible for creating tides. However, the strength of these forces is not constant, as both the Moon and the Sun follow elliptical orbits. This means that their distance from Earth changes over time, with the Moon's distance varying more significantly than the Sun's. When the Moon is closer to Earth in its orbit, its gravitational force is stronger, causing higher tides. Conversely, when the Moon is further away, its gravitational influence is weaker, resulting in lower tides. The same applies to the Sun, although its effects are less pronounced due to its greater distance from Earth. The positions of the Moon and Sun relative to Earth also impact the tides. For example, when the Moon and Sun are aligned with Earth, their gravitational forces combine to create even higher tides, known as spring tides. On the other hand, when the moon and sun are at right angles to each other in relation to Earth, their gravitational forces partially cancel each other out, resulting in lower tides, called neap tides. We'll explore this concept further in the next section. In summary, the positions of the moon and sun relative to Earth, as well as their elliptical orbits, affect the strength and frequency of tides. These factors determine whether we experience higher tides, lower tides, or something in between. Let's delve into the intriguing concepts of spring tides and neap tides. These types of tides result from the alignment of the moon, Earth, and sun during full moon and new moon phases. Understanding these tidal variations will give you a clearer picture of how the positions of these celestial bodies impact the tides on Earth. Spring tides occur when the moon, Earth, and sun are lined up in a straight line, which happens during both full moon and new moon phases. In these alignments, the gravitational forces of the moon and the sun work together, amplifying their combined effects on Earth's oceans. This results in higher high tides and lower low tides, creating greater tidal ranges. Spring tides are not related to the season spring. Instead, the term refers to the springing forth of the water during these events. On the other hand, neap tides occur when the moon is in its first or third quarter phase, and the moon, Earth, and sun form a right angle. In this configuration, the gravitational forces of the moon and the sun partially cancel each other out. This leads to a smaller difference between high and low tides, resulting in more moderate tidal ranges. To recap, spring tides and neap tides are the result of the alignment of the moon, Earth, and sun during different phases of the lunar cycle. Spring tides, which occur during full moon and new moon phases, cause more extreme tidal ranges due to the combined gravitational forces of the moon and sun. Neap tides, on the other hand, happen during the first and third quarter moon phases, leading to smaller tidal ranges as the moon's and sun's gravitational forces counteract each other. In the next section, we'll investigate how local factors, such as coastline shape, water depth, and ocean currents, can influence the height and timing of tides in specific regions. In this final section, we'll investigate how local factors like coastline shape, water depth, and ocean currents can influence the height and timing of tides in specific regions. While the gravitational forces of the moon and the sun are the primary drivers of tides, these local factors can have a significant impact on the way tides manifest in different areas. First, let's consider coastline shape. The shape of the coastline can greatly affect the way tides behave in a particular area. For instance, bays or inlets with narrow openings can amplify tidal ranges, causing what's known as a tidal bore. This is a phenomenon where a large wave travels up a river or narrow bay due to the funneling effect of the coastline. Conversely, a wide, open coastline may experience smaller tidal ranges. Next, let's discuss water depth. The depth of the water in a region plays a crucial role in determining the height of the tides. In deep water, tidal ranges tend to be smaller, as the gravitational forces have a less concentrated effect on the water column. In shallow water, however, the gravitational forces can have a more pronounced impact, causing larger tidal ranges. Lastly, ocean currents also have an impact on tides. Currents are the continuous movement of water in the ocean, driven by various factors like temperature, salinity, and wind. These currents can interact with the gravitational forces of the moon and the sun, modifying the height and timing of tides in specific regions. For example, a strong ocean current flowing in the same direction as the tide can enhance the tidal range, while a current flowing against the tide can diminish it. In summary, local factors such as coastline shape, water depth, and ocean currents can significantly influence the height and timing of tides in specific regions. These factors interact with the gravitational forces of the moon and the sun, resulting in the diverse tidal patterns we observe around the world.